Ready to go. It's all ready to go. All right. Okay, I'd like to welcome everyone to this thesis proposal presentation from Bree. She's going to give us a bit of a journey through the work that she plans to do in her PhD. I'm going to hand over to you now, and we're allocating 30 minutes. And I'll let you introduce it because I've heard it all before and it's a lovely narrative. So I won't interrupt that narrative. Thanks, Bree.
Thank you. Yindyamarra, everyone. That means good day in Wiradjuri. We've had to turn the speakers off, so can everyone up the back hear me okay? Brilliant. All right. So thank you, everyone, for taking the time out of your busy day to come to my thesis proposal review presentation. My thesis is entitled Slow Disaster and Yindyamarra, a two-way research approach to legacy metal contamination on Wiradjuri Country. I want to start with my sincere thanks and appreciation to my supervisors, Dr. Sarah Beavis, Associate Professor Craig Strong, and Professor Brenda Croft. Your guidance and advice has and will continue to be invaluable. I would also like to thank those that have funded my research, including Sarah, the Fenner PhD Discretionary Fund, the Institute of Climate, Energy and Disaster Solutions Game Change Scholarship, the Stan and Jessie Holland Supplementary Scholarship, and the Future Earth Australia Opportunities Fund. Let us begin with an acknowledgement of country. I would like to acknowledge that I live and work on the unceded lands of the Ngunnawal and Ngambri people. I pay my deepest respects to their elders, past and present, and I extend those respects to my own elders, the Wiradjuri elders, the elders of any land on which anyone online is meeting us today, as well as any Indigenous people who are joining me here today. Throughout this TPR, you're going to hear me talk a lot about Indigenous-led research and two-way methodology. I'm going to get in and explain what all of that means as we go, but something that I want to start with is talking about the importance of positionality. Indigenous knowledge systems teach us that your family, your country, your experiences, these are all integral to your research and to who you are. These experiences that make up you are also going to shape your research and how you do your research. So I want to begin this presentation by telling you about myself. My name is Brianna Amy Gordon. I am 25 years old. My mother is Linda Ann Gordon, nee Woods, and my dad is Brett Andrew Gordon. I am blessed to have them still both with me. I descend from the Wiradjuri people of the Koori Nation, as well as Australian settlers, many who came as convicts, and British immigrants who came in the first half of the 20th century. On my Wiradjuri side, I'm come from the Smith family, and we have ties all over Wiradjuri Country. I am a PhD student, a public servant, and I love my pets more than anything. Anyone who knows me knows I have all of my animals tattooed. I was not raised Aboriginal, and I didn't find out until I was a teenager. So in my adult life, I work really hard to decolonise my thinking and promote decolonising research that meets the needs, priorities, and aspirations of Aboriginal people. In short, my being and my research is working to make sure it is in keeping with Yindyamarra. But who are the Wiradjuri people and what is Yindyamarra? So, the Wiradjuri people are the traditional custodians of the Wiradjuri Country, which is central western New South Wales. It's actually very close to Canberra, as you can see down here. It also contains some places you might know, like Dubbo, Wagga Wagga, and Bathurst. Wiradjuri means people of the three rivers. And I'll show you on the map here, we have the Murrumbidgee, which is the Murrumbidgee River. We have the Galari, which is the Lachlan River, and we have the Wamble, which is the Macquarie River. On this slide, I also have the word Yindyamarra. And you might remember that Yindyamarra was in the title of my thesis. Yindyamarra is a Wiradjuri word that doesn't have a direct translation into English, but it is essentially a philosophy that a lot of Wiradjuri people live their lives by. It's also a philosophy that is driving my research. Yindyamarra, in a research context, means to be respectful of Wiradjuri ways, people and country, and to listen closely to Wiradjuri knowledge and to take time to understand how Wiradjuri and Western methodologies can work together, like in a two-way methodology, to achieve enriched and culturally significant research outcomes. That brings me to my research question. What does a two-way research approach reveal about the impacts and slow disaster of anthropogenic metal contamination from legacy gold mining within the former Tambaroora and Turon River gold mining district? And what is its relationship with Wiradjuri Country? This question is broken down into 4 main aims that summarise the 4 streams of work within my PhD. Now, I won't go through it. I don't know if you've had time to read it all, but we'll be going through each aim individually, so you'll have time to familiarise yourselves with them. So, before I do start getting into explaining each of the 4 aims and the work that is involved with them, I want to take a moment. Oh, too far. I want to take a moment to better explain what a two-way methodology is. Simply put, a two-way methodology is the deliberate interweaving of Western knowledge systems and Indigenous knowledge systems to create what we call a third space. This third space is in which both systems can create mutually beneficial outcomes and enrich research outputs that are in keeping with Indigenous needs, priorities, and aspirations. And I use the term weave very deliberately here, because in a two-way methodology system, neither of the knowledge systems are superior over one another. They don't dominate, and neither are they wholly combined. They weave and interlock. The integrity and contributions of each knowledge system is preserved. A two-way methodology is actually a lot like weaving a basket. And here's one I prepared earlier. So a two-way methodology, we have lots of different methodologies that come together, and they're like the strings of the different reeds we weave together. So we've got environmental chemistry, yarding, creative ethnography. And the two-way methodology itself is the strand we use to weave everything together. So when we use a two-way methodology, we create our third space, which is like our basket. And it's strong and resilient because of all of the different strands that you use to make it. And it's also unique and pretty, and it's also very good for lots of different purposes. And yet it stays true to Indigenous culture. So in this research, and I'm going to pass this around so everyone can have a look. In this research, a two-way methodology means that I will ensure that the needs, aspirations, voices, and experiences, as well as the perspectives of Wiradjuri people who partner in this research, their family and their community, as well as Wiradjuri Country, are centred at all points in the research journey. And as a note, in this context, country encompasses the spiritual, emotional, physical connections that Aboriginal people have to the land, air, and country. And it also refers to the holistic interconnectedness of sovereignty, culture, history, ancestry, health, well-being, and spirituality that is tied to all aspects of the environment. Now that we've laid the groundwork, let's get into discussing my actual research. So, as you saw before, Wiradjuri Country is quite large. So I'm focusing on a smaller chunk of it, which is the Tambaroora and Turon River area. So this sits about 74 kilometres north of Bathurst and creates places like Tambaroora, Hill End, Safala, and Wattle Flat as key locales. All of these locations sit along the Turon River or one of its tributary creeks. And this area was a thriving hub of gold mining activity in the second half of the 19th century and the early 20th century. In fact, the Australian gold rush was actually sparked in a fear in February 1851, though that wasn't actually the first time settlers found gold. Not in the context of this research. So by the end of 1851, the population of miners in the area had ballooned to 12,000. And this was going from no one but traditional custodians and the occasional person wandering around. The most popular form of mining from 1851 to the early 1860s was alluvial mining. Though there was some sporadic reef mining, Alluvial mining is what you probably think of when you think of the gold rush, It's the type of mining where you're sitting by the river and you're panning for gold, and you sift through the surface sand and gravel and soil to find the small free pieces of gold that is just floating around and easy to find. This type of mining was very popular because it required very little capital and equipment to get started. It could be accomplished by individuals or small groups. But as the gold that could be found through alluvial mining began to dry up, the attention turned to reef mining, which made up the overall majority of mining within the research area. Reef mining involved the extraction of gold-bearing quartz ore from sometimes very deep underground. And the ore, like this here, would be crushed in a battery stamp until it became like beach sand. And then this sand would be washed over a copper plate, and the copper plate was coated in mercury. The mercury would bind to the gold and create a putty. Putty would be scraped off and burned, mercury would vaporize, and you'd be left with the lovely gold behind. And then the leftover quartz had been washed away. That was a waste product, and it was called tailings. And it was typically dumped in the closest waterway. The official records on gold production in the area didn't begin until 1875. So they did unfortunately miss the most productive period of mining. And for the records we do have, they are inconsistent and not overly reliable. And the reports themselves do admit that they aren't a particularly reliable source of the full gold yield, as many finds from miners would not be reported to the officials. As a result, I can't present a accurate and full amount of gold that was produced in this area during the gold rush. But I do have one estimate that said between 1851 and 1979, 17.01 tonnes of gold was produced through alluvial mining only. And we do know from accounts at the time and looking at the types of material that was produced and what kind of equipment that was at these mines, that reef mining did account for the majority of the mining that happened when you look at the period as a whole. So when you account for alluvial and reef mining, the total amount of gold that was produced would be significantly larger than that 17-tonne figure. As I said before, tailings from reef minings were typically dumped in waterways. Unfortunately, these tailings still contained a lot of mercury, and this would leach into the environment. Lead and arsenic are also significant metal contaminants from gold rush era gold mining. Areas that contain gold are often naturally rich with other minerals like arsenic containing pyrite or arsenopyrite and lead bearing minerals. Pardon? When the gold bearing quartz ore is mined and extracted, tons of other materials and soils are brought up to the surface. And if this material contains arsenic or lead, they then also have the opportunity to leach into the environment. There is a large body of existing work that is investigating the concentration, distribution, and impact of these metal contaminants from legacy gold mining. These studies, like I've got listed here, have consistently demonstrated that elevated levels of mercury, arsenic, and lead are associated with historic gold mining activities. I also have a graph here from a paper by Kay Sultan, who is at the University of Ballarat, which it just shows quite nicely the elevated levels of arsenic right near mine tailings at the former Creswick gold mine in Victoria. So within Australia, the impact of metals from legacy gold mines has been studied fairly extensively in Victoria. There is a pretty significant gap in the literature when it comes to legacy gold mines in New South Wales, and especially my research area, the Tambaroora and Turon River area. We do have one study from 10 years ago that focused on Hill End, but did not extend to the other mining hubs of the region. I also just want to draw your attention to these two little newspaper clippings I've included. So this is from the Turon River diggings, and this is from Sabala. And this is just a mention from the time of quicksilver, which is mercury, pyrite, which is arsenic, and quicksilver again. So we do know that we have records of these chemicals that were present and being used and being found in the materials that were being mined. So this brings us to aim 1 of the research project. A key factor of concern with these metals is that they are capable of moving away from their source point, which is, of course, the mines, and moving into the surrounding environment. So that means that the environment surrounding these mines, especially ones that are downstream or downhill, could be contaminated with mercury, lead, and arsenic. And these metals, they're very toxic. They can cause birth defects, cancer, behavioral changes, fatality, and they can also inhibit plant growth. They don't break down in the environment. They can change forms, but in certain of those chemical forms, they remain toxic and significantly toxic forever. Currently, we don't know what the concentration or distribution of these metals are within this research area. In order to determine that, we're going to have to collect samples of soil, sediment, and water from key locations in the research area. We'll be determining these locations through 3 main methods. The first will be using historic and academic sources to identify sites of likely contamination. So this includes battery stamp sites, tailing dumps, anywhere we suspect that any kind of processing was occurring, and anywhere where waste material would have been left or has migrated to. The second method is using country and geological indicators. So we'll be looking for anywhere where sediment that contains this metal concentrations could have settled and concentrated over time. So this will be found using maps, looking at weather patterns, and just walking on country and seeing what we can observe. The last method, which is probably the most unique way of approaching identifying sites for research, is partnering with Wiradjuri people to yarn and walk on country. And so they're going to be able to identify for us areas of cultural significance or alert us to potential places that would likely contain high levels of contamination that we aren't aware of because we don't live there and we're not as experienced in the country as they are. We are going to be helped in the field with the use of a handheld X-ray fluorescent analyzer, and that's going to allow us to just conduct some preliminary investigations while we're out in the field and see if we're on the right track in terms of where we're looking. Samples will be collected from each site and brought back to the university where they're going to be analysed through inductively coupled mass plasma spectrometry, and I'll be conducting that analysis. When we have the results of the analysis, we will be able to have a look and see if any patterns of concentration or distribution emerge, and we'll also be able to see if any sites have high enough metal concentrations to constitute an environmental or a health risk. The second aim of this PhD will primarily be done through yarning. So yarning is a Noongar word that means conversation or talk, but it's now used as a term much more broadly by Aboriginal and Torres Strait Islander people as a way of learning, sharing, exploring, and being taught by older generations. Yarning is a culturally safe, decolonising research method, and it is often preferred by Indigenous people within research contexts because it privileges their voices, experiences, perspectives, and knowledge, and it also gives them a lot more control over when knowledge is shared and how. And yarning within a research methodology also gives Indigenous partners the chance to be involved in ultimate research decisions and help collaborate in deciding the direction of the research. Yarning is typically conversation or story-based, but it can also include art, song, dance, and performance. In a research context, there are 4 types of yarning. Social yarning, where kin and country connections are shared, and this is very similar to what I did at the beginning of the presentation with you all. There is collaborative yarning, where ideas and any concerns about the research are discussed and the direction of the research is collaboratively decided upon. There is research topic yarning, which is when knowledge and data that is actually pertaining to the research itself is discussed. And then there is also therapeutic yarning, which does unfortunately need to arise if something difficult or painful is discussed during the yarns. Yarning in this research will allow me to collaborate with Wiradjuri research partners to uncover what the potential impacts of anthropogenic metal contamination mean from a Wiradjuri perspective. Through aim 1, I can quantify the numbers, the amount of metal that's in the region, or at least get a good idea of it. But that doesn't tell us what that means for country. And again, for Wiradjuri people, country encompasses health, culture, environment, spirituality, relationships, family, and community all in one. So I'm going to be yarning with Wiradjuri research partners to understand what it means for them that there could be contamination on country, on sacred sites, on sites of family and community stories, and find out what that actually means for them. It is through these knowledge and stories and data shared with me during these yarns that will allow me to achieve aim 3 of this research. Within this research, as dictated by two-way methodology, the knowledge and data that will be shared through the yarns is held at equal importance and significance as the chemical analysis data that we'll be obtaining through aim 1. However, there is a question of how to best represent Indigenous knowledge and data that remains authentic to an Indigenous knowledge system. That's why I have chosen to employ a creative ethnography methodology to create a holistic and faithful representation of the emotion, spirituality, culture, family, and unique knowledge that is shared with me by the Wiradjuri research participants. And I would like to specifically thank Professor Brenda Croft as an inspiration for this type of approach. This will involve creative artworks that are a combination of photography and painting that will be made alongside a traditional thesis output. After the completion of the research, these artworks, along with copies of the research thesis, will be gifted to Wiradjuri research partners, along with their families and communities in an act of reciprocity, and it also to honour the value of their contributions to this work. Additionally, decolonising research theories teaches us that no research is without bias, that the attitudes, feelings, thoughts, and perspectives of the researcher influence the direction of the research. Therefore, I'm also employing creative autoethnography alongside the creative ethnography to ensure that I, as the researcher, remain aware of how I am an active participant in the research and that my thoughts, experiences, and perspectives throughout the research journey will shape the overall holistic narrative of the research. The fourth and final aim encompasses the slow disaster of metal contamination. The term slow disaster reflects the potential impacts of these anthropogenic metals that has been building for over 100 years. So the majority of the gold mining that happened that resulted in the release of these metals happened over 100 years ago, prior to World War I. So why now am I discussing the potential disaster of these metals? Well, the most obvious factor is that they don't break down. They can move throughout the environment, they can change chemical forms, but they cannot be destroyed. So any of these chemicals that are released in the environment are still there somewhere. You just have to find them. And it also means that they can be as toxic today as they were the day they were released. However, the real factor of the potential slow disaster of these chemicals is how they may respond to climate change. To illustrate how environmental metal contamination can be affected by climate change, I'd like to focus on mercury. So elemental mercury is toxic, but the real disaster is methyl mercury. In the environment, mercury binds with organic materials and will settle into the sediment of aquatic systems, so ponds and lakes. Here, under anoxic conditions, bacteria can convert mercury to methyl mercury, which is significantly more toxic than mercury. It's bioavailable, It biomagnifies in food webs, and it also bioaccumulates in tissues. The bacterial conversion of elemental mercury to methyl mercury increases in warmer temperatures. Therefore, rising global temperatures that are associated with climate change has the potential to increase the rate of production of methyl mercury, though this is not a proven hypothesis. Additionally, increasing severe weather events like floods and rainfall that are associated with climate change can increase the turbidity of waterways. And what happens when you increase the turbidity of waterways is that buried mercury-laden sediment can rise to the top, and so you have a fresh batch of elemental mercury that can then be converted into methyl mercury. These same severe weather events could also cause arsenic and lead-laden sediment that had been buried to come to the top and become bioavailable within the environment. However, these same weather events could also mean that these sediments get washed out of the research area. Because of this added uncertainty within this situation, we don't have a solid understanding of how the potential slow disaster of this anthropogenic metal in the environment is working, or what exactly is going on. And we also don't know what risk they could potentially pose to Wiradjuri country and how that risk is affected or may respond to climate change. So we've walked through all the aspects of my proposal. So I'd like to close by just discussing the significance of this research. In addition to the knowledge that will be uncovered through the research aims that we've discussed in this presentation, this work is significant and unique because it takes a decolonising Indigenous-led approach to the study of metal contamination from legacy gold mining in Australia. The research marries together the disciplines of art, history, chemistry, and yarning to produce a rich understanding of the as yet unknown concentration and distribution of legacy metals in the Tambaroora and Turon River area. And it also will reveal the potential impacts that these metals may have on Wiradjuri country and the potential slow disaster that could arise in response to climate change. In combining these methodologies through a two-way methodology, this research will produce culturally informed, Indigenous-led, rich written and visual research outputs that convey the full depth of this research story. This information produced by the research could also additionally be used to craft both state and federal level culturally informed environmentally protective policies. And it also does contribute to Australia's obligations as a signatory of the Minamata Convention on Mercury. All right, so that is the end. Mandangu, which means thank you for listening. And I would again like to thank my supervisors and my funders for their continued contribution and support. And I now also will welcome questions.
So the strong narrative is right throughout. So I'd be really interested to get questions. Yes,
that was great, thanks. You talked about bioaccumulation and the risk of health impacts on people. And I recall from when I last was exposed to work on mercury that bioaccumulation in fish has often been a thing. And, you know, this is happening on rivers where people are fishing and have been fishing for a very long time. So I'm curious, given all that, if people, if others have done work on human health impacts on inland rivers near goldfields in Australia, which is sort of a step slightly down the track that you're taking.
Yes, so you're absolutely right in terms of the bioaccumulation predominantly happening in fish, and as well as of other aquatic animals like mussels and those little thingies that live in sand. I'm not good at animals. And that's predominantly because the methylmercury is formed within aquatic systems. And it also biomagnifies in the food web because the little fish eats it, and then the bigger fish, and then the bigger fish. So by the time you get to the size of fish that we as humans eat, there can be quite substantial concentrations of methylmercury within the fish flesh that we are consuming. And that is how people are predominantly exposed to methylmercury. So the Minamata Convention on Mercury is named after the Minamata disaster, which happened in Japan in, I want to say 1954, in which due to a chemical plant releasing mercury into the waterways, the fish, which was the local population's main food supply, became severely contaminated, and there was a lot of deaths, stillbirths, disabilities, blindness, deafness, deformed limbs that happened as a result of that population having very high levels of mercury. In terms of study of the association between gold mines in Australia and health impacts, I'm not aware of any direct studies that is looking at health. There is of arsenic and lead that looks specifically at they don't create direct links between health impacts, but they do look at potential between cancer instances as well as bioload. But what has been quite common, specifically in Gippsland and the Gippsland Lakes, is the study of mercury in fish and looking at those concentrations, which do constitute in some of the fish they caught enough to be considered a health risk.
And I should add that there's quite recently work being done out in Captain's Flat, looking at health risks associated not with mercury but with lead that's being spread and contaminating the waters and the land surfaces there. So there's quite a bit of recent research. So I just wanted that.
My name's Kath Webb. I've strayed over from the other side of the creek. And I've just learnt that around Bathurst, there's been an extraordinarily large amount of soil loss, wet meadows that were present at the point of colonisation are largely missing now from the landscape, which makes me think that these impacts are going to be, I was looking south of Bathurst, not north, so I understand it's different, but this means that some of the impacts could be a really long way away. What's your kind of geographic thinking? How far are you looking to spread in the downstream sense?
So in terms of where we're looking at the research, there is limitations just based on practicality. So we're really looking at that stretch of the Turon River that I'll flick back to it. Not too far. So looking really at this sort of stretch of the Turon River here. And that's because once we start getting into the Macquarie River, it's a big river, that's going to be hard. And in terms of practicality, that's probably all I can actually get done. But when you're talking about the movement of soil and the instability of the ground and of the constitution of the ground post-colonisation, that is also a really big factor to be considered. So that is a question of, you know, if the contaminants that we would expect to find associated with the gold mines based on the amount of gold we can at least predict or sort of estimate was produced, if it isn't around here, where is it? So because the majority of the contaminants were dumped into rivers, at least with mercury, if they're not here, we expect that they probably would have flown into the Macquarie River and then continued down on that path. And then in terms of the movement of soil, we have to kind of get on country and see if we can look to find where that soil may have gone. Has it accumulated in water, in ponds, lakes? Has it accumulated at the base of hills? And then test that. And it's also worth noting that associated with mining is significant land clearage and significant movement of soil that wasn't associated with mining. So that also did result in muddying up the results and muddying up the patterns of things a little bit when it comes to this research.
Question before about if there are any more research about the impact of mercury and waters and fish. There is this researcher, Larissa Schneider. You might hear from her. So I think she was doing some research in freshwater turtles in the past when I met her. And I think she has a lot of knowledge about that. And she was working also with Aboriginal. Yes, and she did a research with Aboriginal people in the Northern Territory. So she might be a good contact also. So to frame where exactly you can do the research. I think she has more experience with the lakes than the rivers, but yeah, just that. Yeah, you contact her. Okay, yeah, great presentation. Thank you.
Thank you. Any other questions? Thank you very much indeed. A TPR is always a big step to take, and you've certainly taken us on quite a journey. We wish you well in the
Thank you.
next steps that you take. So please join me in thanking Bree.